Right, quick sort algorithm. Similar to the merge sort, it's a recursive algorithm that sorts an array. It's not tested on the AP exam. It's a very good sorting algorithm to actually walk through. So we're going to walk through this. We're not going to show the code, but we're going to walk through it to get the idea. It's very similar to the merge sort again. So as we look through it, you're going to see what happens recursively, and we're going to see what's the difference. So let's go ahead and run this. I'm using the same array, 3, 2, 5, 4, 7, 1. So like I was using the merge sort before. So let's go ahead and check this out. 47 steps. Here we go. The first step is to select a pivot. The pivot is the value that you're going to use to split the array. You see, in the merge sort, we didn't use anything to split the array. We split the array based on its length. So we just cut it in half and put some on the left, put some on the right, all done recursively. But here with the QuickSort, we are going to use a value to split. So what we are saying here is once I choose this value, anybody who is smaller than it is going to go to the left. Anybody who is larger than it is going to go to the right. So these are the values I'm speaking of. So when I pick the 5, if you're smaller than 5, you're going to the left. If you're larger than 5, you're going to the right. The reason for doing that is because we are now sorting as we split. So here's how it works. The pivot got moved to the end, and then we partition the array. So we're looking at the array with the pivot as a value to be used to split the array. And then we move the left bound to the right until it reaches a value greater than or equal to the pivot. So we are looking to move to figure out how to split this. So once we get this value, you're going to move the right bound to the left until it crosses the left bound or finds a value less than the pivot. So we're looking for the split. When we find the split, we're looking to select another pivot. So if you look carefully how this thing moved around and moved around, when we just figure out the split, the 7 is bigger, so it went to the right, and all the other guys went to the left. Now we're about to do the process again. So now we got 2 as the pivot. It got moved to the end. And then we're going to look to move these things around based on the pivot. This is done recursively. You got to remember that. So things are being moved based on the pivot. Now, what you're going to realize is that the pivot, as we're going through, is going to end up, I'm getting to the point where you see the pivot is here, and anybody's on the left is small and everybody on the right is bigger. Now you could see it's pretty fast because as we're splitting, this is the recursive part, this thing is getting sorted. And if we keep doing this over and over again, choosing a pivot, moving things around, what do we have? A sorted array. Now if you look carefully, you would realize that the splitting happens intentionally, unlike the merge sort, where it just splits them based on the length. So it doesn't really matter what goes on the left and what goes on the right, because we're going to merge them back together and we're going to do the sorting there. But in this case, we are splitting based on a pivot, a number, a value. It could be a value in the array, it could be a value not in the array. The point though is to try and split the array such that the left half or the left piece are all the values that are less than the pivot, and the right are all the values that are greater. So once we do that, this thing is going to be sorted 100% recursively. Quick sort. That's it.